All right, let's dive into a really fascinating and kind of paradoxical part of our immune system, type 3 hypersensitivity. This is where your body's own defense force, the system designed to protect you, actually ends up causing a whole lot of damage. It's like a case of friendly fire happening right inside our own tissues. So, how does this happen? Let's get into it.
I mean, it's a wild question, right? You think of your immune system as this super vigilant army, always on the lookout for bad guys. But sometimes, in the heat of battle, the fight itself creates this huge mess, this massive collateral damage. And that right there is the story of type 3 hypersensitivity. The battle can actually become way more destructive than the original invader. So, what are we really talking about here? Well, at its core, it's a cleanup problem. When an invader, an antigen, gets in, our antibodies, specifically one called IgG, act like little security tags and grab onto them. This creates these clumps called immune complexes. Now, normally your body has a great system for clearing these out, but what if there are just too many of them? They get stuck, lodged in your tissues, and that's when the real trouble starts. To really get a handle on how this damage happens, it's helpful to break it down. You can think of it as a clear, three-phase attack. It's a fascinating process, honestly, because it shows you exactly how a perfectly normal immune response can just go completely off the rails. It's a pretty simple sequence, but it's devastating. Okay, so phase 1, the immune complexes form. Phase 2, they drift around and get stuck somewhere they shouldn't be, like in the walls of your blood vessels or in your kidneys. And then phase 3, that deposition triggers a massive, all-out inflammatory response that just tears the place up. Let's look at each of these steps a little closer. Now, this first step, the formation, is absolutely crucial because it turns out size and proportion are everything here. So if you've got way more antigen than antibody, you get these small, slippery little complexes that can dissolve in the blood and travel all over your body. But if you have a ton of antibodies, they form these big, clunky, insoluble complexes that are too heavy to go anywhere. They tend to get stuck right where they were made, causing a very localized problem. This difference is key for everything that follows. And this brings us to phase 3, the inflammation. Once those complexes are stuck, they send out a distress signal. A part of your immune system called the complement system basically sounds the alarm. That call brings in the cavalry, these cells called neutrophils. They rush in to clean up the mess, but they can't eat these giant complexes, so they get frustrated and just start spewing out destructive enzymes everywhere. It's literally called frustrated phagocytosis. At the same time, platelets start forming tiny little clots, blocking blood flow. It's just pure chaos. Okay. So remember how we said the size of those complexes really matters? Well, now we're going to see how that plays out in the real world. It leads to two very different patterns of attack, either a focused, local reaction or a widespread, systemic one. This chart lays it out perfectly. On one side, you have the Arthus reaction. It's local, caused by those big, clunky complexes we talked about, and it happens fast, within a couple of hours. On the other side, you've got serum sickness. This one's systemic, caused by those small traveling complexes, and it takes about a week to really show up. Two different causes, two very different timelines. Let's zoom in on that Arthus reaction. We're talking about localized tissue death. It happens when someone who already has a ton of antibodies gets exposed to that same antigen again, right in the same spot. A classic example is a really severe reaction to an insect bite, but you also see it in things like farmer's lung from constantly inhaling mold spores from hay, or bird fancier's disease from bird droppings. The immune battleground is small, but it is incredibly intense. Now let's flip to the other side of the coin, serum sickness. This is what happens when those small immune complexes travel everywhere. Historically, doctors saw this in people who were treated with horse serum for things like tetanus. Their bodies saw the horse proteins as a massive foreign invasion, made antibodies, and the resulting little complexes settled in their joints, kidneys, and skin, causing a miserable body-wide illness. And this whole mechanism isn't just some rare textbook thing. It's actually the engine driving a whole range of very serious, well-known diseases. The real-world impact is absolutely enormous. I mean, just look at this list. In autoimmune diseases like lupus, the body mistakenly forms complexes with its own DNA. After a simple strep throat infection, these complexes can get stuck in the kidneys and cause serious damage. You see this same process playing out in viral infections like hepatitis, and even in parasitic ones like malaria. It's this fundamental pathway of disease that just shows up all over the place.
So, after seeing all the ways this can go wrong and all the damage it can cause, what's the most important thing to take away from all this? Well, it really all comes down to balance.
And this is the crucial point right here. The immune system isn't necessarily broken or defective in this scenario. It's actually doing its job. The problem is one of quantity. It's a normal system that has just been completely swamped by way too many of these immune complexes. So many that it just can't clear them away fast enough. And that's what leads to all the collateral damage we've been talking about. And that leaves us with a pretty big thought for the future. You know, these immune pathways we have are ancient, they've been with us for a very long time, but our world is constantly changing, constantly throwing new things at us. New pollutants, new viruses, new allergens. So the big question is, how will our bodies react when these brand new antigens meet these very old and very powerful defense mechanisms? It's a question researchers are trying to answer every single day. If you like this video, then please like, comment, and subscribe.